Okay, still on the theme of complex numbers, we're now going to do question 17 from 2017. So this is slightly different, it's to do with roots. So question says that z equals, so root 1 is 2 plus I. And part A is state a second root. Well, that's always easy because your complex conjugate is always a root. So if 2 plus I is a root, 2 minus I is a root. So that's an easy first question. Then it says, find the value of Q and the remaining roots. So what we've got to think of, if these are roots, what is the factor associated with those roots? So just like in higher, when you found your factor using your synthetic division, for example, if you got a factor of 2, a root of 2, then your factor was actually x minus 2. So these are our roots. So our factors, there's going to be a factor z minus 2 plus I. And there's going to be a factor z minus 2 minus I. Okay, so it's important to know the difference between the roots and the factors. So if these are both factors, if I then actually multiply these together, that's going to still be a factor. So that's what we're going to do. And you just multiply these out like you would multiply out double brackets. So z times z, z squared. Z times minus 2 minus I, so that's minus 2 minus I z. These two is going to be minus 2 plus I z, and then the last two will be plus 2 plus I, 2 minus I. So we just need to tidy this up. So we've got z squared, we've got minus 2z, we've got plus iz, minus 2z, minus iz, and then multiplying these out just like double brackets, 2 times 2, 4, you're going to get minus 2i plus 2i and minus I squared. So we can tidy that up further. So we've got z squared, we've got minus 4z, because you've got minus 2z, you've got a plus iz and a minus iz that cancels out. You've got a minus 2i and a plus 2i that's going to cancel out. So all we're left with here is 4 minus I squared. Now remember, I squared equals minus 1. So this is minus minus 1, so that's plus 1. 4 plus 1 is 5. So z squared minus 4z plus 5 is also a factor. Now what we need to now do is we need to divide the polynomial that we've got by this to be able to work out what Q is and also the remaining roots. So it's algebraic division to do that. So I'm going to give myself a bit of room. So your algebraic division is just like normal numerical division. So we've got z to the 4 minus 6z cubed plus 16z squared minus 22z plus q. And we were dividing by z squared minus 4z plus 5. I think that was correct. Okay, so we're only looking at the highest power of z's. Z squared divides into z to the 4, z squared times. So basically you're just doing that, divide by that. Okay, so it's z squared times. So it goes in z squared times, write that above the z squared terms, and then you're going to multiply all of this by z squared. So you get z to the 4, you get minus 4z cubed, and you get plus 5z squared. Now I would just put plus 0 in those spaces because we're doing a subtraction to see what we've got left. So q minus 0 is q. Minus 22 minus 0 is minus 22z. 16 minus 5 is 11z squared. Minus 6 minus minus 4 is minus 6 plus 4, so minus 2z cubed. Then we need to do this, divide by z squared. So that means it goes in minus 2z times. So multiply all of this by minus 2z. So it gives us minus 2z cubed. It gives us plus 8z squared. It gives us minus 10z plus 0. Subtraction again. Q minus 0 is q. Minus 22 minus minus 10 is minus 22 plus 10, so that's minus 12z. 11 minus 8 is 3z squared. So now we're doing 3z squared divided by z squared. So that's 3 times. So plus 3 times all of this by 3. 3z squared minus 12z plus 15. Now, this should equal 0 when we do a subtraction, because remember, this is a factor, so there should be no remainder. So if that has to equal 0, then if you look at this, q minus 15 has to equal 0, so q has to be 15. That minus that 0, that minus that 0. Okay, so basically q equals 15. Now, in order to get the rest of our roots, this is also a factor. Okay, so we've now got that's a factor and that's a factor. We know the roots of this because that was the roots that we started with. How do we get the roots of this? Well, we need to factorise that. Okay, now that doesn't factorise nicely. So in order to factorise this, we need to use our quadratic formula. So that's what we're going to do now. Okay, and you need to learn the quadratic formula. So, quadratic formula is z equals minus b plus or minus square root b squared minus 4ac all over 2a. So that's going to be minus minus 2, so plus 2 plus or minus the square root of minus 2 squared minus 4 times 1 times 3 all over 2. So that is 2 plus or minus the square root of minus 2 squared is 4, and that's minus 12. 4 minus 12 is minus 8 all over 2. So we need to tidy that up. So that's going to be 2 plus or minus square root 4 square root minus 2 all over 2. And the square root 4 is just 2. The square root of minus 2 is going to be root 2i, because remember that's like root 2 times root minus 1, and the square root minus 1 is I, and then that's all over 2. So these 2's all cancel out and we're left with 1 plus or minus root 2i, or I root 2. Okay, so that's your other roots. So our roots are, I'll just list them, z1, the root we were given, 2 plus I. z2, complex conjugate, 2 minus I. z3, 1 plus I root 2. And z4, 1 minus I root 2. And that is all our roots. Now part C tells us to show the roots on an argon diagram. So that should be easy enough. Okay, so argon diagram, real, imaginary, and you just plot each one. So 2 plus I is 2 along and 1 up. So that is Z1. Z2 is 2 minus I. So that's 2 along minus 1 down. That's Z2. Z3 is 1 plus root 2I. So root 2I is a little bit more than 1. Okay, so it's 1 along. And we'll just say root 2 up. So that's going to be there, and that's Z3. And Z4 is 1 along and minus root 2. So Z4 there, and it's as simple as that. So that's that question complete, and that was worth 8 marks.